Hello, my name is Anders, and in this video I will present our work Image-Free Classifier Injection for Zero-Shot Classification, which was primarily done at the University of Tübingen. This is a collaboration between Anders Christensen, Massimiliano Mancini, Almut Sofia Köpke, Professor Ole Winter, and Professor Zeynep Akata. To begin this presentation, I would like to give a bit of context on the classical zero-shot learning classification task. In this task, we are given a dataset of labeled images of so-called scene classes, along with a set of semantic class-wise descriptors, such as attribute vectors or textual descriptions of the classes for both seen and unseen classes. This allows us to reason about the visual properties of images from unseen classes, and with a range of techniques proposed in the zero-shot literature to train a downstream classification network that can categorize both seen and unseen classes. In this work, we present the task of image-free zero-shot learning, in which we no longer assume to have access to any images, not even from the seen classes. Instead, we are given a model already pre-trained on the seen classes. Since a large variety of pre-trained deep learning models are readily available online, we pose the question: given a pre-trained model, can we extend it to desired but missing classes without using images from seen or unseen classes? For our approach in this work, we therefore set out to find if we can find visually discriminative information in the pre-existing classification weights of the given network and attempt to generalize from these in order to infer new classifier weights for the unseen classes. We do this similarly to the classical zero-shot learning literature by leveraging class-wise semantic descriptors from seen and unseen classes as our learning signals by pairing classifiers with their corresponding semantic descriptors. Our solution, which we term IKIS or image-free classifier injection with semantics, is a simple dual autoencoder structure with a four-way reconstruction loss. We train this by pairing classifier weights and class descriptors, and this will allow us to infer new classifier weights when doing inference on semantic descriptors of unseen classes. The model is trained with cosine distance loss and can optionally include unseen classes during training as well. For inference, we simply give descriptors of unseen classes to input to IKIS, and as output we get classifier weights which we can append to the classification layer of the given and otherwise pre-trained classification model. The classification model can then be deployed as any other classification model, but will now be able to also classify images from the unseen classes. For comparisons on this newly proposed image-free zero-shot learning task, we adapt existing methods in the zero-shot learning literature. Our IKIS model consistently achieves the best performance on both the image-free zero-shot learning as well as the generalized image-free zero-shot learning task. Further, IKIS allows us to regress classifier weights across datasets. We show that IKIS can lead to non-trivial downstream classification performance on free datasets even when using a generic ImageNet pre-trained classification model and using simply word embeddings of the class labels of the source and target datasets. Finally, we perform a number of ablation studies demonstrating that IKIS is able to generalize from even a very small number of seen classes. As a sanity check, we also conduct a failure case analysis that shows that even for classes for which the downstream classification accuracy is poor, it is because of misclassification happens between semantically very similar classes. In this case, tree sparrow is being confused with chipping sparrow, house sparrow, field sparrow, and white-crowned sparrow. We take this as indication that indeed the classifier weights from which we train on encode visually discriminative information that is useful for the task. Thank you for your attention. The paper is available on arXiv, and code is available on GitHub with the links and QR codes shown on the screen.